This is the second part of the lesson on line integrals. We will learn now how to evaluate some of them. Here is the objective of this lesson. At the end of the lesson, you are expected to solve line integrals by using some techniques. Before we go to some examples of evaluating line integrals, let us again recall the evaluation techniques discussed in the previous video. So number one, express all quantities in the integral in terms of a single variable. Number two, if the integral is with respect to x or y, then the curve c and the function f may be expressed in terms of the relevant variable. Number three, if the integral is with respect to ds, normally all quantities are expressed in terms of x. Then lastly, if x and y are given in terms of a parameter t, then t is used as the variable. Let us have this example number one. Find the integral of x times the quantity 1 plus 4y dx along the curve c, where c is the curve y equals x squared, starting from x equals 0, y equals 0, and ending at x equals 1, y equals 1. So as we can see in the integral given, so we have here the variable of integration is with respect to x. And it concerns only 2 points along the curve C, where we have the given curve y equals x squared, and we have the points or values of x and y. So that when we now evaluate this integral, y here may be replaced by x squared. And the limit that we will be using are the values of x, which are x equals 0 and x equals 1. So writing now the corresponding integral, again we write the integral of quantity of we have x times the quantity 1 plus 4y dx along the curve C. And this is now equal to, we have the integral of x times the quantity 1 plus 4, and we're going to replace y with x squared. Because as I've mentioned, the variable of integration is dx. So we're going to make all the variables in terms of x. And then the limits that we're going to use is from 0 to 1. We have it as x equals 0 and x equals 1. So if we're going to integrate this now, so let's now have x multiplied by quantity 1 plus 4x squared. So we have it as x plus 4x cubed dx from 0 to 1. And if we're going to integrate now this function, so we have here an integral of x squared over 2 plus we have the integral of 4x cubed dx is 4x to the 4th over 4 from 0 to 1. So let us cancel 4, and this gives now x squared over 2 plus x to the 4th from 0 to 1. Applying now the limits, we have it as the upper limit first, we have quantity 1 squared over 2 plus we have 1 raised to the 4th power. Then we have the lower limit as assigning now 0 to x, we have 0 squared or 0 quantity squared over 2 plus quantity 0 raised to the 4th, wherein this will give us 0. So the answer now here is 1/2 plus 1, and this can be further evaluated as 3 over 2. So this is the answer for this given integral. Let us have another example. Example 2. Find the integral of x times the quantity 1 plus 4y dy along the curve C, where C is the curve y equals x squared, starting from x equals 0, y equals 0, and ending at x equals 1 and y equals 1. So again, as this integral concerns only points along C, and the integration to be carried out is with respect to y. So that we will now replace x in terms of y. And how are we going to do that? We're going to take the square root of both sides so that we can now have x equals square root of y. And then the limits that we will be using here is we have the values of y equals 0 and y equals 1. Let us now evaluate. So again, we are given here the integral of x times the quantity. You have 1 plus 4y dy along the curve C. And this is now equal to, we're going to replace x by square root of y because let us derive y equals x squared. And solving for x, so we're going to raise both sides by 1/2. So this now becomes y raised to 1/2 equals x, or simply x equals y raised to 1/2. So with that, we now have x equals y raised to 1/2. Then we have quantity 1 plus 4y dy. And the limits that we're going to use is from 0 to 1. So let us simplify this expression. So we now to multiply 1 y rather raised to 1/2 times the quantity 1 plus 4y. So this gives us quantity y raised to 1/2 plus 4 y raised to 1/2 plus 1 is 3 over 2 dy. Then let us now integrate each term. So the integral of y raised to 1/2 dy is y raised to 1/2 plus 1. That is 3/2. Then you have over 3/2, or this can also be written as 2/3, which is the reciprocal of 3/2. Then you have plus 4, then times y raised to 3/2 plus 1 is 5/2. Then the reciprocal of 5/2 is 2 over 5. Then the limits is from 0 to 1. So we are now ready to evaluate using the limit 0 to 1. So let us apply first the upper limit. So we have here now 2/3 times the quantity 1 raised to 3/2. Then we have 4 times 2 is 8 over 5. Then we have 1 raised to 5/2. Then applying the lower limit, we have it as, so we have minus 2/3 times the quantity 0 raised to 3/2 plus 8 over 5 times 0 raised to 5/2. And in this case, this will be equal to 0. So therefore, we have here now 1 raised to 3/2 is still 1 times 2/3 is 2/3. Then we have here 1 raised to 5/2 is 5/2. Then times, or rather 1 raised to 5/2 is 1 times 8 over 5 is 8 over 5. So simplifying our answer, LCD is 15. Then obtaining the numerator, here we have 15 divided by 3 is 5 times 2 is 10. Then you have here 15 divided by 5 is 3 times 8. That's equal to 24. So therefore, this is now equal to, you have it as 34 over 15.